Dear students, let us today discuss Coimbatore University BSc 3rd semester Geometrical Optics chapter session 1. Myself Dr. Niranjana A.R., Assistant Professor of Physics. Light is a form of energy which evokes visual sensation of objects. The observation regarding the studies of light reveals that the light travels in straight lines from one point to another point and shows that its propagation is rectilinear. This fact leads to Fermat's principle of least time, a basis of geometrical optics. It is remarkable and important principle in optics which explains why light propagates along straight lines and the laws of reflection and refraction. Let us first understand optical path. The velocity of monochromatic beam of light in a material medium is different from that in vacuum. If c and v are the velocities of light in free space and in a medium respectively, the ratio of c by v is defined as the refractive index of the medium. This is denoted by n or mu. Mu is equal to c by v, call that equation 1. Also, c is equal to f lambda, where lambda is the frequency of vibration. When light is propagated from one medium to another medium, the frequency remains the same if lambda and lambda m are the wavelengths in free space and medium, then mu is equal to lambda lambda m, or lambda is equal to mu lambda m. Let us call it equation 2. An optical path is defined as the product of geometrical distance and the refractive index of the medium. Let us now understand Fermat's principle. According to this principle, a ray of light from passing from one point to another point through a set of media by any number of reflections and refractions selects a path along which time taken is minimum or the least, or the path actually taken by a ray of light in passing from one point to another point is the path of least time. Observe the figure. From the above figure, the path ABC, which comply with the laws of reflection, is shorter than any other imaginable path from A to C. Example, the path ADC. The length of ABC is equal to the length AC dash, whereas the length actually equals the length of the broken line ADC dash. From the figure, it is obvious that the refraction of light does not obey the principle of shortest path. The path ABC, ADC, etc. are longer than the path AC. By considering all these facts, Fermat stated the principle of least path. Suppose P and Q are the 2 points in the same medium. As in figure 3, light needs the time dt to travel the distance dl in the medium. dt is equal to d by v of l, or dl by v. Call that equation 1. The time required to travel the total distance is pq and is given by t is equal to integration between the limits p to q of dl by v. Call that equation 2. As V is equal to C by mu, the equation 2 can be written as T is equal to 1 by C integration between the limits P and Q of mu dl. Call that equation 3. The quantity integration between the limits P and Q mu dl is called the optical path length delta. If different paths are considered from P to Q, then Fermat's principle states that dt by ds is equal to 0. Call that equation 4. ds is the path difference between any two paths under comparison. Equation 2 can be written as, equation 3 can be written as t is equal to delta by c. Call that equation 5. According to equation 5, the principle can be restated as light travels along a path having the minimum optical path length. Thus, the condition may be now expressed as d delta by ds is equal to 0. Fermat's principle of extremum path. It is found that in number of cases, the time taken by the light is not minimum but maximum. Example, spherical reflector, and in case of elliptical reflector, the time taken is same for all the paths. Statement: a light ray traveling from one point to another point will traverse a path for which, compared to all neighboring paths, the time required is a minimum or a maximum or stationary. This is also known as Fermat's principle of stationary time. Derivation of Snell's law of refraction using Fermat's principle. Consider a plane surface S separating two media. Let A and C be the 2 points lying in the two different media. To show that the time taken by the light to travel the path AC is minimum, the total path of the light is AC is equal to AB in medium 1 and BC in medium 2. Let K be a point on the surface of S and has the coordinates x, 0, z. The optical path through the point K of x, 0, z is given by delta is equal to AK times mu1 plus KC times mu2, which is equal to mu1 times square root of x square plus a square plus z square plus mu2 times square root of x minus c whole square plus b square plus z square. Apply the Fermat's condition to get the actual path. Dou delta by dou z at constant x is equal to 0. Therefore, z is equal to 0. This shows that the incident ray, refracted ray and the normal lies in the same plane, which is first law of refraction. Applying the second condition, dou delta by dou z at constant x is equal to 0, we get dou delta by dou z at constant x, which is equal to mu1 by 2 times 2x by root of x square plus a square plus z square plus mu2 by 2 of 2 into x minus c by x minus c whole square plus b square plus z square, which is equal to 0. That is mu1x by square root of x square plus a square plus z square is equal to mu2 times x minus c by x minus c whole square plus b square plus z square, or mu1 sin I is equal to mu2 sin r, or sin I by sin r is equal to mu2 by mu1, which is Snell's law of refraction. Let us study some multiple choice questions. The product of the geometric length of the path of light follows through the system, and the refractive index of the medium is known as Fermat path, optical path, ray path, optical path difference. The correct answer is optical path. Next question. What will be the time taken by a ray of light traveling from one point to another by any number of refractions and reflections follows that particular path? Options are highest, least, maximum, moderate. Answer is C. Next question. Name the person who formed the principle of least time. Pierre de Fermat, C.V. Raman, John Kepler, Albert Abraham Michelson. The correct option is A. Pierre de Fermat. These are the references for this session 1, Optics by Ajoy K. Ghatak, 6th edition, textbook of optics, revised edition for BSc classes as per UGC model syllabus. Authors N. Subramanian, Brijlal, and edited by M.N. Avadhan. And this is some link, internet link. And next reference, e-sources and books. And fifth reference, Wikipedia. Thank you and all.